Hello everyone, I'm João Boas from Brazil, and I'm here today to present ocean waves as a great potential as a renewable energy source. Renewable energy is by definition energy that is collected from renewable sources which are naturally replenished in a human timescale. The competition is fossil fuels such as coal and natural gas that can be very harmful for the environment and to human health. Here there are some important factors for switching to renewable energies. The first one, they emit much less or even no greenhouse gases when compared to fossil fuels. Renewable energy emits almost no air pollutants, and they are also more stable economically, because since its sources do not get depleted in a human life at time scale, it can be considered to have a constant supply, avoiding economic fluctuations. We can also highlight that renewable energy sources normally cause less environmental impact than fossil fuels. An example of that would be the explosion that happened in the Gulf of Mexico in 2010, causing a huge environmental and economic damage. These are some examples of renewable energy: solar energy, wind energy, hydroelectric energy. No other one that I'm going to be talking about in this video is energy collected through ocean waves. Different from the most part of the popular renewable energy, there are plenty of ways to get energy from ocean waves. The power generation technologies under development can be classified into three groups: onshore, that means on coast; near shore, that means close to the coast, generally between 20 to 40 meters depth; and offshore, far from the coast, greater than 40 meters depth. As you can see, there are multiple methods to extract energy from the ocean waves. It is interesting to note that wave energy is actually a form of solar power. When the sun's rays hit the Earth's atmosphere, they heat it up. Around the globe, a difference in temperature naturally occurs, causing air to move from hotter regions to cooler ones, resulting in wind. As winds move across the seas, some of their kinetic energy is transferred to the water, creating waves. Essentially, wave power is generated by the action of the wind, and still, ocean waves have more power potential than solar and wind energy. As it can be seen through the graphic, the potential of this kind of energy is enormous. The theoretical annual energy potential of the coast of the United States is estimated to be as much as 2.64 trillion kilowatts per hour, which is equivalent of about 64% of US electricity generation in 2019. Actually, when technological advancement is good enough, it's expected that ocean waves energy can supply up to 15% of global demand. Now we are going to calculate the estimated energy that a sea wave carries. From the linear wave theory, the total energy of a wave per unit of length is given by the first equation. Also from the linear wave theory, the velocity of propagation of the wave is given by the second equation. When we sum up all the equations proposed and do the right substitutions, we get this result for the potency carried by wave, showing us that it is proportional to the height of the wave and the period of the wave. Substituting the values for ocean water, consider a density of 1020 kilograms per cubic meters and gravity equals to 9.81 meters per second squared, we can get this constant result. And there are three main paths to extract energy from the ocean waves as shown in the figure: through a turbine, through a linear electric generator, and through hydraulics. Here are some examples of the use of ocean waves to produce energy around the world. In Gibraltar, for example, it is expected that these devices are capable of providing around 15% of the region's demand. And the last one is a prototype case of study in the University of California, Berkeley, exploring different mechanisms to collect electricity from ocean waves. Now we're going to explore one possible way to try to maximize the energy taken from this technology. This device is showing great results, having one of the higher conversion rates into electric energy available so far, about 35%. It works based on a hydraulic pump, hyperbaric chamber, hydropneumatic accumulator, turbine, and an electric generator. The process is the following: fresh water in a closed circuit is pumped into the hydropneumatic accumulator, which stores water under high pressure from the pumps. The wave, as it passes through the flow, transfers the movement vertical to the mechanical arm that functions as a lever, displacing the piston of an axial suction pump and repress. A lever multiples the gravity force of the fluid by 10 times, thus increasing the capacity of pumping pressure considerably. The high-pressure water is pumped in a closed circuit to the hydropneumatic accumulator. Then a low-controlled valve moves the turbine connected to an electric generator. The accumulator is connected to a gas lamp with high pressure inside the hyperbaric chamber. This subsystem works as a pressure stabilizer for water that is pumped intermediately. Then accumulator water is directed by a jet moving the turbine. And finally, the turbine is attached to the electric generator to produce electricity. Now, this is the model of the hyperbaric chamber and the hydropneumatic accumulator used. We can therefore calculate the velocity of the jet responsible for making this process possible according to Bernoulli's equation. Looking now at the turbine model, we can calculate the torque generated by the jet, and then calculate the power produced by the system that will in further future become electricity. Now, as a conclusion, we can notice that the ocean waves has a great potential to become of the leading and renewable energy to be used by our society in the future. So, thank you so much for your attention. I hope you enjoyed the video, and see you.